A very good evening to all of you who are joining with us from around the globe to know more about the quality assurance engineering practices. Few weeks back, the whole world was crippled by a major defect in Windows operating system. Unfortunately, this defect was detected by the users like you and me who got to see a blue screen on our Windows devices. What was the effect of this? Airports, hospitals, lot of important organizations were crippled. They couldn't operate, and a lot of people were facing troubles. Windows had an issue which downgraded their reputation. All this could have been eliminated if this bug, this simple memory leakage bug, could have been captured earlier. This is the importance of modern strategies for early defect detection. So let me welcome you all to this masterclass on modern strategies for early defect detection. To start this masterclass, let me ask you a simple question. If you are someone who is starting a startup, a new technical project, or even working in a technical project, do you have an approach to test the product you are building with? Is your approach the bugs to be captured by the users, end users, and clients in the production environment? Then obviously that is not a very good approach. It will give you a lot of trouble and it will demerit the value of your product hugely. So what is the approach you should be taking to test your product to give the best quality for your users, for your clients? That's what we are going to discuss today. Now let's look at how traditionally software products were tested. I believe most of you are familiar with this life cycle. This is the software development life cycle. At the very beginning of software development practices, this was the procedure followed by many organizations, even the biggest organizations in Earth right now. So there's a structured cycle which starts with planning, then analysis, design, implementation, then comes testing and integration, and finally maintenance. This is a structured process, and the testers, quality engineers, the people who are responsible for the quality of the product have to wait until the fifth step, testing and integration, to test this product. But is this the best practice for the modern day software development? Yes, this SDLC, software development lifecycle, and testing according to the waterfall method at the later part of a project, it had its advantages. It still has. As I said, this is a structured approach. So there are clear and distinct phases providing a well-organized and systematic process. This ensures everybody is following up to the process. And we can work on documentations as much as we want because each phase takes time and it gives the designers, quality engineers, developers to work on the documentations and keep things clean. And we can predict what is going to happen in the project because at the beginning of the project, we have strictly defined the phases and we are going to stick to it according to the SDLC, software development life cycle with waterfall method. But is this practical in the modern software development practices? Are these advantages relevant to today? Today, most teams are following the agile methodology. The problem with the waterfall method and the software development life cycle in the traditional methodology was they were not ready to accept change. If a change should come, it should come at the very beginning in the planning phase. But if during the development phase, if changes come, they have to wait until the latter part in the maintenance or uh, until they start a new complete cycle. This is not valid to today's practices. We want to give updates to our users as quickly as possible. Think about the mobile applications you use day to day. They get updates very often, even without we are knowing, we are getting new features, we are getting bug fixes through updates. Teams are working in an agile atmosphere in today's software industry. So today in such agile environment, what are the disadvantages of this traditional testing method of waiting until all the development and every other activity is finished? These are the disadvantages. As I said, it's very inflexible. We have to wait until a phase is completely finished to see what are the changes, and we are not going to adhere to those changes according to the SDLC because we are going to stay in a strict structure. It is very time consuming. Design phase take a lot of time, then development takes a lot of time, then testing takes a lot of time, and we have to wait until all these phases are over to give our users, our clients, a new feature that they are waiting for. And the biggest disadvantage is late testing. Testing begins only after the development phase. So developers might have made a lot of mistakes during their developments. Developers are also humans, and there could be many more bugs that were introduced during the development phase. So we are going to identify those bugs completely after the development, and then when the testers, the software quality assurance engineers report those bugs, there's going to be a lot of rework, a waste of time. So how can we eliminate these disadvantages of traditional software testing methods? That's where the most regarded, most rewarded approach comes, which is the shift left testing method. This shift left testing method, take the title shift left testing and look at this graph, this diagram. We are pushing the testing practices, the testing activities completely to the left side of the development spectrum. We want to start testing as soon as the requirements are identified in a new software development project. We don't want to wait until the development is finished. This is simply shift left testing. Shift left testing is a method where testing is performed earlier in the development process, earlier as much as possible. This means the testers and the quality engineers have to change their mindset about testing, and the developers and all the other stakeholders have to change their mindset about testing as well. This is a hand-in-hand effect. We have to work with business analysis, project managers, product owners, different kind of stakeholders hand in hand in order to make sure shift left testing approach is followed by a team. Now let's talk more about shift left testing. But before that, let's look at this next graph, which is shift left versus traditional model. As I said, in the traditional model displayed here in the blue color, you can see testing is completely focused to the latter part of a certain project cycle. We are testing when the testing phase begins, and also when the development is mostly over, we have to test whatever it is developed. But look at this yellow color graph, how early the testing activities begin. From planning and design to developing, we are doing testing. We are, as software quality assurance engineers and testers, we are involved in the planning phase and the development phase to make sure there are no bugs in the requirements, or there are no bugs, easily catchable bugs in the development phase itself. So I have been talking about bugs a lot. Actually, what are the bugs? Bugs are simply errors, flaws, failures, or fault in a software application program. Like the example I gave at the very beginning of this session, the infamous Microsoft blue screen issue. Bugs can happen because these are mistakes. Softwares are developed by humans. More the bugs, lesser the quality, and lesser the user's confidence in the application. This is the main issue with the bugs. The more we introduce bugs to one of our beloved products, the users drastically begin to lose the confidence in that particular software product. That means we are losing our client, we are losing our users. We have to make sure the product we give to our clients and users are up to the utmost quality, to the perfect quality with minimal bugs. Now, to catch these bugs, what can we do? That's what we are going to discuss next. To catch these bugs in earlier phases of the software development spectrum, as much as possible, we need to implement tests like a pyramid. Before that, let's look at this graph as well. This graph shows how finding bugs at a later phase in a software project cycle can affect a lot to the cost of that software project. Look at how much is the cost in earlier phases like requirements and architecture. When we decide the requirements and architecture, look at how lesser is the cost. But as we move towards the right of the project cycle, towards the production and post-release, the cost of fixing a bug goes higher and higher and higher. What are these costs? The effort we have to fix a bug. We have to rework on a feature we have already developed. That's the cost. And we have to spend time again and again on fixing the same issue. That's a cost. And again, we have to spend money to whatever the resources we are using to fix this bug. That is a big cost. And also, we lose the confidence of the end users, especially if a bug is found in production and post-release environments. We lose the confidence big time. That's the biggest cost, according to my opinion. So, to eliminate this cost as much as possible, we need to do thorough testing, and we have to implement tests in a pyramid shape like this. Now, why we are telling to implement test in a test pyramid, especially in this shift-left approach? We want to cover as much as possible test in the development phase itself with unit testing, because unit tests are small, they are easy to automate, and they run very quickly, so that we can identify issues, bugs, defects in our functions at the earliest possible by running these unit tests. And then we need to have component testing and integration testing to make sure all the components and different integrations, even the third-party integrations that we have in our product, are working fine. Finally, we need to implement end-to-end tests like manual and exploratory test, automated end-to-end test, UI test, API tests. We need to make sure the end-to-end flow is working. But according to this pyramid structure that we define in a shift-left approach, unit test should always be higher in number. Integration test should be lower than the unit test, but should be more than the end-to-end test. An end-to-end test should be the least amount. Comparing the test case numbers, the amount should be lesser than unit tests and integration tests, because end-to-end tests can be costly. They are complex to develop. We have to replicate a whole user journey in this end-to-end test. So we are testing as much as possible individual functions using unit tests in the development phase itself, and integrations we thoroughly test using the integration test. Finally, when everything comes together, we do end-to-end tests. We can automate as much as possible, and also we can do manual exploratory testing as well. Now let's talk about what are the benefits of this shift-left approach. I'm going to talk about 7 benefits mainly. So at the end of these 7 benefits, you can decide for yourself why you should adopt this shift-left approach for your software development project today. The first one is early defect detection. This is what we need to do. Eliminate the bugs as soon as they are introduced to your software development project. Now, bugs can be there in the requirement phase in itself, as I said. If there's a logical issue in the requirements you have, if there's a issue in the design, these can be corrected at the requirement phase itself. That's why we need to involve quality assurance engineers and testers in the requirement discussions itself, so that they can give their opinion on how to improve the quality of your product. By reducing the cost of to reduce the cost of fixing bugs, we can identify and fix defects early in the development process. The most important thing is this process improves the quality immensely. We can catch the bugs early as possible, and it will make sure your clients, your users are getting the best result in the application. Their experience will be satisfactory. So this should be the ultimate goal, and this should be the mindset. The next advantage of this shift-left approach is faster feedback loop. To make the feedback loop faster, we have to integrate continuous integration with our testing. This continuous integration means we can help basically the developers to address issues quickly and ensure that the code base remains stable throughout the development process. So to do this, we can use different tools. There are tools like SonarQubes, which evaluate the code base and give an evaluation about this code quality. This is just one integration, and we can integrate this code commits and pull requests in a way where the tests are run automatically. We are going to talk more about this in the coming up slides on how to implement this shift left approach. So the best result of this fast feedback loop is reduce rework. Developers receive immediate feedback on their coding. When they code a new function, a new feature, and do the commit, a test automatically runs and give the feedback to the developer whether there's a bug, a defect or not. If there's a defect, the feature doesn't move forward from there. The developer can fix the issue before even the testers and quality engineers catch the bug in the later development phase. So this is very important. We need to make the feedback loop as fast as possible to get the best out of this shift left approach. The next thing is enhanced collaboration. When it comes to shift left approach, we are talking about cross-functional teams. In earlier days, there were times where development team worked separately, testers worked separately, quality assurance engineers worked separately. There were no proper communication between them. This is not valid for modern day agile software development. If we are going to practice shift left approach in our software development projects, there should be a close collaboration between developers and quality engineers especially, and also there should be a collaboration between designers, business analysts, and all the stakeholders in the team should work together. So this quality is not just a responsibility of quality engineers anymore. It's a responsibility of everybody. Quality engineers and testers drive that responsibility, but everyone else have to give their best support to the quality engineers to make sure the product is up to the expected quality. The next advantage of this shift left approach is improved requirement understanding. When quality engineers and testers are involved in requirement discussions itself, designing discussions itself, they get better understanding about the requirement. They can analyze the requirement and understand what kind of test coverage is needed for the product or the feature that these developers are working on, so that we can make sure the involvement of testers help the designing comprehensive to design comprehensive test cases to cover everything, to catch every single bug possible before we do a release. This is one of the biggest advantages of involving quality assurance engineers and testers in the earlier phases of requirement analysis and designing itself. Reduce risk. This is another very important advantage of this shift left approach. In traditional software testing methodologies, the risks are higher. There could be a lot of bug leakages into the production environment because testing are done at a very later phase. Where testers are working with time pressure to deliver the product to on deadlines sometimes. But when the testing is done in earlier phases, when the requirements are analyzed perfectly, when the requirement bugs are eliminated using static testing methods, and the developers have implemented unit tests, and when the developers are using continuous integration to make sure all the integrations are working perfectly and executing tests, we are reducing bugs a lot. We are reducing bugs in each phase without waiting for the later testing phases. This helps the project by reducing the risk of releasing unwanted bugs into production environments. And let's move on to the next advantage, which is the increased efficiency. Automated testing uh, and using automated testing, we can increase the efficiency a lot. Now, for example, if we have used traditional testing methods and used manual testing only in your product that is being developed, it will be a tedious effect for testers. A lot of resources will be wasted, a lot of time and money will be wasted on testing. But if we can automate tests, and if we can put effort to automation from the beginning itself, especially if we cover the unit test automations, integration test automations, and also end-to-end test automations, we can save money, time by just letting the test automations do the work. And you have to sit and watch the quality of the product in your CI/CD pipelines. So this is the modern approach. Without waiting for testers to test at the last moment, we are giving the testers the capability to automate test. This is why modern quality engineers should possess the skills for coding and development as well, so that they can write automation scripts and develop proper automations to cover the necessary test coverage for a software development project. The next thing is, by detecting these bugs earlier and making sure tests run automatically, we can reduce the delays and accelerate the release time immensely. This is why most of the agile teams in the modern software development industry are able to deliver their features, their updates, their bug fixes as quickly as possible and with lesser and lesser bugs. We rarely see most of the good companies introducing bugs in their live environments, but they are introducing new features, new updates every now and then. This is the power of automation. We can make sure the existing features are not affected by making sure a proper test automation coverage is run, and we can introduce new features again into making sure they are also covered with test automation. So this is a must for modern software testing practices. The final advantage I'm going to discuss with you today is the enhanced customer satisfaction. Delivering a product with few defects and a high stability gives a lot of pleasure to the customer. The end result of the entire team, entire software development team, including the testers and quality engineers, should be to make the customer happy. And if we can get good feedback, if we can get early user feedback using user acceptance testing, we can make sure there are no bugs released to the production environment, and we can make sure it is up to the expected level. So these are the 7 main advantages I wanted to talk with you today. So next thing is, we now know how shift left testing could be advantageous. Let's see how we can make sure shift left testing is implemented correctly in your software development project. So steps to implement shift left approach is like this. Again, I'm giving you 7 steps that you can follow in your team so that you make sure the shift left approach is implemented correctly. Number one, we can adopt agile and DevOps practices. This is very important. If you haven't implemented an agile practice in your development environment yet, this is important to get all the uh, all the collaboration from all the users and implement a proper agile structure in your development environment. There are different agile practices like Scrum, Kanban. You can choose what suits your development team and introduce them. The benefit of adapting this agile and DevOps practices we discussed already. By working as an agile team, we get the feedback in the fast loop, so we can make sure bugs are found earlier and eliminate those bugs earlier as well. The next one is we have to embrace test-driven development. We call it TDD simply. Now, how we can implement TDD is this is all about writing tests first and then developing your functions or features according to the functions you have written. I'm sorry, I'm getting some feedback. Yes, seems it's good now. So this, as I said, TDD is writing test cases first. Especially, you can implement unit test cases in your teams and write unit tests. And I didn't. I'm sorry, I'm getting the feedback again. Nadeem, there's some noise coming. Yes, sorry about that. In TDD, what we do is we write the unit test first so that the developers can first write the unit test for their functions and then write their functions and implement their functions and features so that the unit test should pass when the development is done. So in traditional methods, testing was done later, but what we are encouraging to do with TDD is writing tests first. This ensures that testing is integrated into the development process from the very start. And also it's important to automate this unit test to make sure we have the test coverage, as I said, and you can use JUnit or NUnit. These are famous unit testing tools and implement these unit tests. So test-driven development is like this diagram says, writing a failing test first, make the test pass. If there are issues, we change, we refactor, and making sure we are writing tests again for whatever the changes we make. Simple as that. So moving towards the implement behavior. Implementing behavior-driven development. This is PDD. Now, what is the difference between TDD and BDD? Test-driven development is primarily, it is concerned with the correctness of the internal logic and implementation. But when it comes to BDD, BDD emphasizes user stories and scenarios. We describe the expectation, the expected behavior of the system in a way that the users, mainly the stakeholders, the non-technical stakeholders understand. So we can define test cases for an example like this. When a user When a user logins to the system and given that they are provided the correct username, password, then they should be able to log into the system correctly. This way, everybody can understand what is the test case is about, and this is focusing on the behavior, because at the end, user expectations are about behaviors. They want, we are talking about user journey, how a user should have a best quality journey in a product. So we are thinking about the behavior of users and developing test cases on that. This is a method you can use to make sure implement test cases from the very beginning of your project and make sure the all test cases you have written cover all the scenarios that your user might follow. So BDD is also a very important part of shift left testing. What you need to implement next, as I already said, you need to give priority to automating test processes. The manual testing time, where testers spend hours testing websites on mobile devices and whatever other devices, spending time a lot, spending their effort a lot, that is bygone. We have to make sure a product has a good automation test coverage. Now, I have given the most prominent tools that are used in the testing industry right now, Selenium and Appian, just for examples, but these are just couple of tools. There are plenty of tools available. You can decide on what automation tool you are going to use to automate your test cases depending on the requirement of your team. It may depend on the languages you use, whether you are using Java, JavaScript, or Python, or any other language. There are testing tools, automation tools to cater all these languages with different requirements. So it's better to do a study on these tools before you choose a tool. Do a study on the cost of the tool, what is the language, how easy or hard for that particular tool to be used. That way you can make sure you have the best tool to automate your software development project and its test cases. And I promised I'm going to talk more about continuous testing, continuous integration, and continuous development, continuous deployment. We can use tools like Jenkins. Jenkins is the most famous one when it comes to CI/CD, but there are many more tools provided by AWS, Azure, and also even GitHub and GitLab has CI/CD integrations and different tools integrated with it now. So you can choose up to your preference, your easiness, whatever the tool, but implementing CI/CD is important. When your development team is releasing a bug, releasing a feature, you should make sure the continuous integration and continuous deployment pipelines passes 100%. So you can introduce pipelines where, for example, when a user is developing, when a developer is creating a new feature, he writes some automation test cases, unit test cases, integration test cases, and do the commit immediately in Jenkins or GitLab or whatever the integration CI/CD tool you are using. There should be triggers to run test automations, end-to-end test automations, unit test automations, and make sure all these integrations are getting green ticks, which means you are passing all your end-to-end tests, unit tests, and make sure no bug is leaked through new developments. So this is why implementing CI/CD is very important. The next one is continuous integration. Continuous integration is, I spoke about this earlier as well, where we can encourage the developers to commit the code changes frequently and use CI/CD tools like Jenkins, GitLab, Travis CI to automate the build and testing process. So CI and CD should go hand in hand, continuous integration and continuous deployment. Whenever you integrate your code with the code base, test should run. Whenever you release a new deployment using continuous deployment, test should run. So make sure you have a strong CI/CD pipeline implemented in your project. And this automated builds and tests ensure that each code commit triggers automatically, providing immediate feedback on the quality of the product. So these immediate feedbacks, the green ticks and red color warning marks, these are very helpful for us to make sure the software, the product you are providing for your client, your users, is up to the utmost quality. The next thing is early and continuous requirement validation. We spoke about this when I explained what is shift-left testing as well. Involve testers as early as possible. Don't think that testers and quality engineers are not important for requirement discussions. Involve them, get their feedback, get their idea about what can be improved more in these requirements. Do you see any obvious bugs in the requirements itself? These kind of discussions should happen within your team in order to implement shift-left testing. And another thing is, while the developers are developing the feature or the software product they are working on, quality engineers also have a responsibility to make sure they develop the test cases for that product as early as possible, giving it 100% test coverage. Then discuss these test steps, test cases with the developers and other stakeholders. Discuss what can be implemented as unit test, what can be implemented as integrated test, and what can be implemented as end-to-end test, and make sure all the aspects of the test pyramid is covered by the moment the product is about to release. So this is how we can make sure the defects, the bugs are found and eliminated as early as possible. Finally, continuous monitoring and getting continuous measurement is really important to make sure this shift-left approach is working correctly. Define and track metrics such as code coverage, defect density, test execution times. There are so many metrics you can define for your project. And use different tools. There are many tools available today. Just for example, you can use tools like QMetry, which is one of the most famous tools to make sure the defects and the bugs and also the test cases in a project are tracked correctly. So there are many tools like that. I'm just giving one example, but there are many tools that you can use to define metrics that should capture the quality of your product and to make sure that metrics are met at every release. This is very important. And this improvement of the quality of in your product is a continuous process. Use the collected metrics to identify areas to improve and work on improvements in every software every sprint cycle of your software development project. Just don't limit the quality to the expectation of the clients and users. Go beyond the expectation of the client and users and make sure you develop the best software product for your client and user. Finally, what I have to say is quality assurance engineering is a mindset. So this is a quote from the infamous Henry Ford, who founded Ford Motors. Quality means doing it right when no one is looking. As quality assurance engineers, as testers, as developers, and all the other stakeholders of a development team, we have a responsibility to make sure to take charge, to take responsibility, and make sure we provide the best quality to our client and our users. So inviting you to do that and inviting you to implement shift left approach if possible in your teams to make sure your teams meet the highest expected level in software quality, the deliverables you give to your clients. Let me wind up this session today and open the forum for any questions that you might have. You can send the questions to myself or Nadeem, or you can simply type the questions in the comments so we can give you answers. I'll give you like few minutes if you have any questions to send our way. So send any questions you have our way. We are ready to give you answers anytime. And today's materials, this presentation, you can get this. If you are a registered user, you can get this. We will be sending to you, and you can give us feedback through the form that will be shared as a link right now. And then from there, we will be sending you this material as well. The things that we discussed today will be shared with all the participants. All right, let's wind up the session for today. Thank you everyone for joining. Thank you for your time. If you have comments, questions, please send us our way. We value your feedback. Thank you everyone. Good night.